Recently, we have explored how to work with EBS volumes. Now, it is crucial to understand a concept related to these EBS volumes, the EBS snapshots. This represents an effective method for backing up the data contained in EBS volumes. Therefore, EBS snapshots are a mechanism for backing up data from EBS volumes. EBS snapshots are stored in the service called Amazon S3. Amazon S3, or Simple Storage Service, is an AWS storage service. So, when you create a snapshot of an EBS volume, it is stored in Amazon S3, and also they can be restored back as EBS volumes. When you restore a snapshot as an EBS volume, the new volume starts as an exact replica of the original volume that was used to create the snapshot. Snapshots are incremental. This means that when multiple snapshots of an EBS volume are taken, only the blocks that have changed since the most recent snapshot are saved. Let's see a graphical representation to help you understand this in detail. Here we have a volume which is 10 gigabytes in size, and we take the first snapshot of this volume known as snapshot A. Since this is the first snapshot, it will be a full snapshot of the EBS volume and will be 10 gigabytes in size. Now, let's say that after taking snapshot A, 4 gigabytes of data has changed on the volume. Therefore, when you take a snapshot, in this case, snapshot B, it will only contain the data that has changed on the EBS volume. So, snapshot B will only be 4 gigabytes in size. However, to restore snapshot B to a functional EBS volume, you will also need the remaining 6 gigabytes of data. So, for the remaining 6 gigabytes, it references snapshot A. Therefore, snapshot B contains the data that was changed, which has a size of 4 gigabytes, and for the remaining 6 gigabytes, it is based on snapshot A. As a result of this mechanism, the size of snapshot B is only 4 gigabytes. Now, let's say that after taking snapshot B, 2 gigabytes of data were added to the EBS volume. Then, when another snapshot is taken, which would be snapshot C, it will only contain 2 gigabytes of data. However, to restore it back to the EBS volume, we need the remaining data as well. So, for the remaining 4 gigabytes, snapshot C references snapshot B, and for the remaining 6 gigabytes of data, snapshot C references snapshot A. Therefore, if each of these snapshots were full snapshots, the total storage required would be 10 plus 10 plus 12 gigabytes, for a total of 32 gigabytes. On the other hand, with incremental snapshots, the total storage needed is 10 plus 4 plus 2 gigabytes, for a total of 16 gigabytes. Incremental snapshots save the time needed to create the snapshot and also save storage costs. Now, this was all based on incremental snapshots of the same EBS volume. But how do incremental snapshots of different volumes work? Let's briefly look at this graphically. We start with volume 1 of 14 gigabytes in size, but only 10 gigabytes are occupied with data. Then, we take a snapshot. In this case, it would be snapshot A of this volume, copying those 10 gigabytes of data. We then create volume 2 by restoring it from snapshot A. This means that volume 2 now has the same 10 gigabytes of data that volume 1 had at the time the snapshot was taken. Now, over time, we add another 4 gigabytes of data to volume 2. After this, we take another snapshot, in this case, snapshot B. And here's the interesting thing. Since we already have a copy of the first 10 gigabytes of data from snapshot A, we only need to copy the new 4 gigabytes of data to snapshot B. This is how incremental snapshots help us save space and time. We only copy the new or changed data. Snapshot B is an incremental snapshot of snapshot A, although it was created from a different volume. This means that we do not need to store all the data again, only the ones that have changed. However, since snapshots only capture data that has been written to the EBS volume at the time the snapshot was created, if there is data that has been cached by applications or the operating system itself, it will not be included in the snapshot. Therefore, AWS recommends detaching the EBS volume before taking the snapshot. If it is a root volume, It cannot be detached. Therefore, in this case, AWS recommends stopping the EC2 instance before taking the snapshot. Also note that snapshots can be copied from one region to another, allowing data migration. Let's look at a use case for this. Suppose we have an EBS volume in the US East region and we want to create a copy of this volume in another region, the West region. EBS volumes cannot be copied from one region to another. Instead, we can create a snapshot of the EBS volume in this same region, then copy it to another region, and then restore the snapshot again as an EBS volume. Snapshots can then be copied from one region to another, allowing EBS volumes to be moved to different regions. Snapshots can also be encrypted and shared both with other AWS accounts and publicly. Users who have access to your snapshot can use it to create their own EBS volumes, and the original snapshots will not be affected. So, I hope it is clear how EBS snapshots work. See you next time.